Good morning, everybody. I'm assuming it's morning, but probably for most of you, it's actually afternoon when you open these lessons, but always morning for me. So we're wrapping up chapter 14 today, stoich. This is a pretty short, easy lesson. Having a calculator would be handy and your data book because you're going to need some molar masses. And we're working on page 234 in your study guide. So what we're going to be doing today is doing the math behind electroplating with electrolytic cells. So as the example says in your notes, when electroplating a metal object, you can control the time and the amount of electrical current, or the amps. So on your power supply, you can dial in the amps to what you want. Then you decide how long you want to run the cell for. And those two variables together will determine the amount of metal that is deposited on the object. Okay? All right. In the production of elements, refining of metals, and electroplating, it really is the quantity of electrons, which is from your amps, that determines the mass of metal that's plated at the cathode. Remember, it's always the cathode where you're hanging your base metal to get it plated. So in these cell stoich questions, you need to have a balanced half reaction for the cathode, usually the cathode, sometimes the anode, but the question will tell you. So you need the half reaction because you are interested in this. You need to know the number of electrons that are being transferred per atom of metal. So it's like a molar ratio, but instead of a balanced chemical equation, it's just a half reaction. And it's an unusual molar ratio because it's the ratio of electrons to atoms that are being oxidized or reduced. So some things you must remember in chemistry, there's always those little topics where you have to remember some things and then you have to be able to apply them. So in cell stoichiometry, what do you have to remember? You have to remember that current, which is always given to you in amps, needs to be converted to coulombs per second. Amps doesn't work for us. It doesn't cancel out, but coulombs per second does. So the conversion is every amp gets switched to coulombs per second. So 64 amps becomes 64 coulombs per second, and that's useful. Time must be in seconds. So the conversion, usually these things are given in minutes. So if you had 4 minutes, you'd have to go 60 seconds per minute. If you had 4 hours, you would times it by 3,600 seconds per hour to give you seconds as your unit for time. Faraday's constant. This will be brand new for you guys. Faraday's constant's in your data book on page 3 or 4, the miscellaneous page where you have all of the units and symbols and you have the specific heat capacities. Anyway, it's on that page. You use it enough that you kind of just remember it. 9.65 times 10 to the fourth coulombs per moles of electrons. It's key because this is how we're going to cancel out coulombs or moles or electrons when we're solving these problems. You always need this constant for every cell stoich question. Moles of electrons, which we'll get from our half reaction when we get the molar ratio. And the mass of the metal, you often need that one as well. And that will be usually from the molar mass because that's going to give you the units of grams per mole where we get our grams of metal. Okay, if it's an electroplating question and you are given current or time, then that's your hint that it's cell stoich, and you also need to go and grab Faraday's constant because that's how you're going to solve for current or time or cancel them out. It's all about unit analysis. Every one of these questions we're going to be solving by units. Okay, so here we go. Let's dig into it. Practice makes perfect. Okay, what amount of electrons? Amount means moles. So we're looking for what moles of electrons is transferred in a cell that operates for 1.50 hours at 0.625 amps. Okay, we're given time and current, so that means we're going to need Faraday's constant, 9.65 times 10 to the fourth coulombs per mole electrons. Okay. Now, in this question, we are looking for moles of electrons. So we want this. So we're starting this off. We're looking for moles of electrons. So we're going to flip Faraday's constant and put moles of electrons on top. 9.65 times 10 to the fourth coulombs on the bottom. Okay, so now we have the unit we're looking for on top. We need to get rid of coulombs. In this question, they do not give us coulombs, but remember what I said, amps needs to get converted. So that becomes 0.625 coulombs per second because 1 amp is 1 coulomb per second. Okay, so now I'm going to write that up here, 0.625 coulombs per second. And as you can see, coulombs cancel out. Okay, so now I have my moles of electrons, but I still have seconds, and I don't want that. I just want moles of electrons. So I need to get rid of seconds, and I have 1.50 hours, which can be converted. Remember, 3,600 seconds in an hour. So that gets rid of the hours. That gives me my seconds, and now I can cancel out the seconds. And when all is said and done, this is all I have left is moles of electrons. And then the math, multiply everything on top, 0.625 times 1.50 times 3,600, and then divide by 9.65 times 10 to the fourth. And you get that answer, 0.034974 moles of electrons. It sounds like a really small number, but if you remember that 1 mole is 6.02 times 10 to the 23rd in a mole, that's atoms per mole. And then we have 0.0349 moles. We actually get a pretty big number, 2.25 times 10 to the 22. 2.25 times 10 to the 22 electrons. So sounds like a small amount of electrons, but it's billions and billions and billions transferred in 1.5 hours at 0.625 amps. So all about solving for units. So let's continue on. Okay, so this is a more typical type of question. You're not asked for moles very often. Usually you're asked for a mass. So what mass of copper is deposited at the cathode? So we have copper forming at the cathode. So my half reaction at the cathode would be copper 2 plus, gaining 2 electrons to form copper. Because remember, the cathode is always your strongest oxidizing agent, gaining electrons. So there's my half reaction. This is in the cathode of this electrolytic cell. You got 12 amps. Let's convert that to coulombs per second. 40 minutes, so that's going to get converted to seconds as well. Okay, what mass of copper? So mass of copper, so we're looking for grams. Where do I get grams from? There is no grams given in this question, but it's copper. So if we know it's copper, we know the molar mass of copper is 63.55 grams per mole. So there's where our grams come from. So I'm going to write that on top. 63.55 grams per mole. Okay, got my grams. Let's get rid of the moles. This is where I would use Faraday's constant because it has the unit moles in it. So I'm just going to write it off to the side here. Okay, there's Faraday's constant. So when I write it in, am I leaving it like this or do I flip it? Flip it to cancel out the moles. Moles of electrons, 9.65 times 10 to the fourth coulombs. Okay, so moles cancel out. So now I'm left with my grams, good, but I also have electrons and coulombs, and I have to get rid of those. Coulombs I can get rid of here. Coulombs per second. Okay, coulombs is gone. Let's get rid of seconds. We got to get rid of electrons and seconds. So which one first? Camilo, your choice. Okay, electrons it is. How do I get rid of electrons? Ooh, oh, right here. So I have electrons on the top. So I'm going to put 2 electrons on the bottom, and I'm solving for grams of copper. So I'm putting copper solid on top. 1 copper produced for every 2 electrons used up. Okay, electrons cancel out. If I quit right now, I've solved for grams of copper per second. I just want grams of copper. I have to get rid of the seconds. So that's where I will put in my 40 minutes times 60 seconds per minute. Minutes cancel out, and my seconds cancel out. Okay, all that's left is grams of copper. It's a terrible color, isn't it? Terrible choice. Grams of copper. So you do the math. Multiply everything on top, divide by everything on the bottom, and you get 9.48 grams of copper, 3 sig digs. Okay, that's really cell stoichiometry in a nutshell. That's what it looks like. So my face is getting cut off here. We're going to do 2 more examples, and then we'll call it a day. Short lesson today. And our last lesson in this chapter. Okay, this is a cell stoich question where they don't tell you cathode and anode. You have to figure them out. So we have an electrochemical cell with zinc and lead. So that's also going, it doesn't say this, it's a poor question. It should also say zinc and lead ions in the electrolyte. Or actually in this case, it would be just lead ions. So let's say it was like PbNO3. Okay. So when you go to look this up, you discover that zinc is our strongest reducing agent right here. And lead 2 plus is our strongest oxidizing agent. Oh dear, I did not choose a good example there. I got to flip it. It's going to be zinc 2 plus and lead. Zinc 2 plus and lead. Okay, I got to change this. Zinc nitrate, which gives us zinc 2 plus. Now we have an electrolytic cell. Okay. Okay, so zinc 2 plus will be our strongest oxidizing agent, gaining 2 electrons to make zinc. And lead, did I get that right from memory? Lead solid, yes, goes to lead 2 plus and 2 electrons. Okay. The reason I'm doing both half reactions is because this question is asking you for the mass lost at the anode and the mass gained at the cathode. So here is our cathode gaining electrons, and here is our anode losing electrons. Okay, 6 amps, 6.00 coulombs per second. Okay, 3 hours. Let's just convert that right now. 3 hours times 3,600 seconds per hour, which is 10,800 seconds. Okay, so there's my coulombs per second and seconds. Okay, let's do the anode first. So what are we looking at? Mass lost at the anode as the solid lead breaks down. So mass lost, mass of Pb lost. So we're looking for grams. Where do I get grams from? Molar mass of lead, which is 207.2 grams per mole. Okay, there's my grams of lead. Let's get rid of moles. Faraday's constant. Moles of electrons, 9.65 times 10 to the 4 coulombs. Okay, moles are gone. Let's get rid of electrons. So my half reaction, and it's 1 lead for every 2 electrons. Okay, electrons are gone. So right now I have grams of lead per coulomb. I have to get rid of coulombs. And that's where this comes in, 6.00 coulombs per second. Okay, coulombs are gone. Last thing I have to get rid of is seconds, 10,800 seconds. Okay, all my units cancel out. I'm left with grams of lead. Run all the numbers through and you get 9. Whoops, let's try that again. Flip the page and you get 69.6 grams of lead, solid, lost at the anode. Okay. Zinc, 2+ at the cathode. Okay, so now we'll do this. So if you guys want, if you're feeling comfortable, you can pause the video and you can solve for zinc, 2+. Pretty straightforward, pretty much same pattern, so mass of zinc. So if you want, pause the video, go ahead and solve for it, see what you get. Okay, so I have to start off with molar mass of zinc, which is 65.41 grams per mole. Okay, everything else is going to be the same, believe it or not. So Faraday's constant. Moles are gone. 1 zinc for every 2 electrons, same ratio in the zinc half reaction. Okay, and 6 coulombs per second. Coulombs are gone. 10,800 seconds. Seconds are gone, and we will get grams of zinc. Okay, and the mass of zinc is 22.0 when you plug all that in. Okay, so there's our 2 half reactions done. Mass cathode, mass anode, mass lost at anode, mass gained at cathode. Okay, it's our last one. Wow, we're done chapter 14. We're done everything in redox. Hope you've enjoyed this chapter. Believe it or not, it's my favorite. I don't know why. Students, just once you get the idea down of oxidizing agents, reducing agents, all the rules, it kind of makes sense. Redox stoich's a little hard, but electrolytic voltaic cells, you get the patterns, they're not too bad. So hopefully you agree with me, you enjoyed this chapter. And then our next one is a little tougher, I'm not going to lie. Acid-base chemistry and equilibrium. First half not bad, and then it gets a little trickier towards the end, but we'll be into end of May by then, and you guys will be pretty excited to be done the course. So we'll be ripping along, and life will be good. It's only going to get better from this point on. Okay, so last one. How long does it take to oxidize 20 grams of lead? How long does it take? Okay, so we're looking for time in seconds. We've got an electroplating cell, and it's using 20 amps, which is 20 coulombs per second. Okay, we're solving by units, so we're looking for time in seconds. So I'm going to start with my seconds over 20 coulombs. There's what I want. Let's get rid of the coulombs. I'll need Faraday's constant, and this time we're leaving it the way it is, not flipping it, so that I have coulombs on top, moles of electrons on the bottom. Okay, coulombs are gone. So now I've got to get rid of my moles and electrons. So electrons, I'm going to need the half reaction. This is lead oxidizing, so oxidation is a loss. So Pb loses 2 electrons to become Pb2+. So that's 2 electrons on top for every 1 Pb solid. Okay, electrons are gone. I have to get rid of moles. How do I get rid of moles? Molar mass. Lead is 207.2 grams per mole. So I'm going to flip it. Moles on top. 207.2 grams on the bottom. Moles are gone. So what have I got now? I've got seconds per gram. I just have to get rid of grams, and it needs to go on top. 20.0 grams. Boom. Everything cancels out. It's incredible. Okay, plug it all into your calculator, and you get 931 seconds. In your study guide, there are, I think, 4 of these questions to do. That's it. take you 10 to 15 minutes. Nice short day. And you have that practice assignment that I gave you yesterday, review assignment. It's like 7 pages of questions. Do as many as you would like to do. I've given you the answers to today's assignment, and the answers to that chapter 13-14 review that started on page 280 and went all the way up to 287. You're really feeling like you've got a lot of time to burn and you're enjoying this stuff, you can do some multiple choice practice questions as well. Or just do those instead. And this is all optional practice, and those start on page 288. And there's a ton of them. There is a ton. And the reason I put so many in is because students are starting to gear up for the diploma exam and they want lots of practice questions. There is no diploma exam this year. There may not even be a final exam this year. That's still to be determined. So you don't need to do all of those. Do what you need to do to get a good handle on this chapter before you get your review assignment and review quiz tomorrow. Okay, take care, everybody, and I'll see you guys tomorrow.